Hi, in this video, I'm going to walk you through how to model semi-automatic assembly line into Kaizen Copilot tool and achieve line balancing. As you might be knowing, in the modern practice, many of the assembly lines are now semi-automatic, which means if you look at the all the activities that is required to build a product, some of them is done manually, some of them is done by cobots, and some of them are done in machines. And while machine is performing its operation parallelly, an operator is also working. This changes the game of how balancing can be achieved. And we have that all set up in Kaizen Copilot. For this example, using smartphone, we were able to capture all the operations of a line where some of the operations were manual, some of the operations were automatic, where the machine was performing the job, and in some cases, the operator was loading the part to the machine and waiting for machine to process. So in this example, we captured one of our production line which had 6 stations, and so it's simple, like we do in Kaizen Copilot. First, we captured all the station operations using the smartphone. We uploaded the video into the station design. We completed the time study, and then I have imported all those videos to this particular line balance. Okay, and also one of the other use case in this particular example is for both pre-assembly station and station 1, there was a single operator who was working there. So that can be simply configured by clicking on these three dots. Again, click on edit, and here I can assign an operator. So for pre-assembly station, it is operator 1. Similarly, for station 1, I have assigned again the operator 1. You can as well see here, it displays here, or you can also go in and verify here. Likewise, if there is one operator who is walking to different station and working, you can generally assign one operator to multiple stations. And wherever, in the video, in the operation, wherever you see a machine action, you are supposed to change the action type into machine, or if it is done on a machine but even man time is required there, you can make it as man plus machine. If it is only man operation, change the operation type to man. If it is walk, you can choose walk or waiting. So as I mentioned, in this example, there were a couple of operations done by machine, couple of operations done by man plus machine, and most of the other were done by man. Here, I have imported all the operations performed in this semi-automatic line. I have changed the action type wherever required to machine, and the next step is to configure walk. To do that, I click on walk configure, and here user is supposed to enter what is the walk time per meter. Generally, it's 1 second per meter, but it can vary based on organization, or if you are using a different PMTS standard, for example, MTM, as per MTM, it's 1 second per meter, but whereas other PMTS modules can have different. So as per your organization requirement, you can enter this. And then here we have a distance matrix. So here you are supposed to enter the distance between pre-assembly station to station 1, pre-assembly station to similar to station 2, 3, 4, and all the other stations in the assembly line. And to do this, you really don't have to scratch too much of your head. You really need not really take a measurement tape and really measure the distances. For that, we have given you this quick references. Example, if somebody walks a 7th step, it generally means the distance between station A and station B is 5 meters. Or if somebody is walking 1.3 steps or 1.5 steps, it generally means the distance is 1 meter. So with this, you can quickly determine what is the distance between your consecutive stations within your line, right? And this is not mandatory, this is optional. And the advantage of adding this is if you don't want to while rebalancing, if you want to keep your station configuration same, but if you want your operators to move across different station and work, our system will automatically understand if single operator is assigned to more than one station, and while you rebalance, it automatically adds the walk time that I'll show you in the results page. So once walk is configured, the next thing is to go to the next page, the work content page. In this page, you will see all the operations or tasks that is required to build the product from all the stations. And it is important as a user for you to update the precedence relationship here. So clicking on this, you can autofill chronology, but most of the time there is a flexibility that, for example, after step 4, either step 5 can be performed or step 8 can be performed. So this type of precedence relationship can be defined here. Once precedence step is defined, you can also define clusters. So for example, let's say you have broken down an activity into minor steps. For example, reaching to a bin as one step and assembling that screw to the part as another step. But while rebalancing, if those are broken into movable units, what issue could happen is one of the operator might be assigned to pick screw, but another operator might be assigned to install and tighten it. It doesn't make sense. So in that case, you can always use our merge cluster option, but we always recommend as a best practice to make sure each action is one movable unit between the stations. But yeah, of course, that's not practical. But whenever you want to group something together, you can always use our manage cluster option. Click on that and define a cluster. Like here, I have defined assembly 1, assembly 2. And then once you have designed a cluster, whenever you see in this table, you have a column with the name cluster. And for example, in my case, I wanted to cluster step 6 and 7, which is pick plastic component from bin and place it onto the fixture, pick screw and secure the plastic component in the main unit. So I want these two steps should always be assigned to a single operator or station. To do that, I'll simply go into this drop down and select assembly 1 and select assembly 1. So all the steps with assembly 1 will be clustered as one movable unit while rebalancing. Similarly, I had another case where picking up the component, rotate and place it back, and then securing screw should always be done together. So I've defined it as assembly 2. And then, yeah, so these are the two things that you're supposed to do in this page. And then, uh, you know, uh, you remember, right? So for the first two stations, that is pre-assembly station and station 1, there was only one operator resource who was working in both. So our system has understood that and it has assigned the same resource for pre-assembly station and as well as station 1. We can see here operator 1 everywhere. And then you also remember that we changed some of the step action type to machine because those were conducted by either cobot or an automatic machine. So wherever the system recognizes that there is an action type called machine, it automatically assigns a machine resource. So chronologically, the first step with the first action type as machine is identified as machine 1. So in station 1, we have machine 1. And since this particular step number 4 requires both man and machine, for example, placing part inside the machine, right? So this is kept inside the machine. So both resources are utilized. So we call it as man plus machine. Hence, the system has automatically assigned both operator who is working in the station and the machine which is available in the station to this particular action. Similarly, we can see there's another machine on an automatic screwing machine, so which is machine 2. And then, yeah, for man plus machine actions, it has assigned both a machine resource and an operator resource. Uh, I think similarly, we have an other case where there is machine 3, and there are some activities related to that which both man and machine does. So these things system automatically will recognize that within a station there can be two types of resource. One is machine, other one is operator. And all the action type which has man, it assigns to operator. And if it is sees a machine action type, then it assigns a resource called machine. And this is always editable. If you want, you can change it. Okay. Yeah. So once all of this is done, the next thing to do is to add takt time. So you can click on this pencil icon here and then define takt time. And for takt time, there are two ways to do. One is direct entry. If you have already calculated your takt time based on your demand and available time, you can directly enter that value. Or if you want to calculate within the system, you can also do that. To do that, you should have the following information. One is number of working days per year. What is the total production time per day? What is your total scheduled downtime or break time per day? And then what is your customer demand volume per year? So if you enter all of these details, the takt time will be automatically calculated. Or if you already know your takt time, you can directly enter the takt time. And you can define takt time not only for current year, for the consecutive or following years as well. So add your takt time and click on save. Once this has been configured and verified, now we can generate results. Okay, let me show you what are the new things in the results page. The first thing is the precedence diagram. Now you can also identify which steps belongs to station 1, station 2, and the other station 3 or different stations. So how do you identify that? With this blue arrow. So wherever you see a blue arrow, that's an indication that the following step is happening in a different station. In this example, the pre-assembly station has 3 steps: step 1, step 2, step 3. And then the station 1 has steps from 4 to 11. And then here is a transition, and from step number 12 to 18 happens in station 3, and so on. While looking at the blue arrow, you can identify when does a new station starts. And then when I go to line balancing, here I can see all the 6 stations I configured. And now let me go to operator balance, where it's only about operator. And now you can see there are 5 operators only, because if we remember, as per our line configuration, a single operator works between both pre-assembly and station 1. Hence, you see 6 stations and only 5 operators. And now let me take to the Yamazumi chart. Here we can also see the machine, right? So machine load. So for example, in this particular line, there are 5 operators and 3 machines, and these are the load of each resources. And you can also see, since we configured the walk distance between the stations, and the system has understood that operator 1 works in both pre-assembly station and station 1, and that is the reason it has automatically assigned the walk step. So yeah, you can also see that it mentions that pre-assembly station to station 1, the time is 1.2 seconds. Similarly, once he finishes all the activity, he's supposed to come back to pre-assembly station, so another walk time is added. And then this is the time the other resource in the station 1 takes. So if I enable the station association, I can see that operator 1 belongs to both pre-assembly and station 1. Machine 1 belongs to station 1. For station 2, we have both a manual resource and a automatic resource, that is machine. Similarly, station 3 has only one manual resource, station 4 has only one manual resource, and station 5 again has one manual resource and one machine resource. So this way we can configure a semi-automatic line and see load at each resources. Similarly, I'll show you the SWCT chart, and our SWCT charts can understand what tasks are happening in parallel, what tasks are happening in sequential in nature. So for example, this is the station 1 where there are 3 activities and all 3 activities are done by man, which happens in a sequence. And then this is station number 2 where we have some automatic operations as well. So for example, the first activity where picking the part and placing in the fixture is done by an operator, and then the application of grease is happening automatically. Generally while the grease machine is running, the operator is not idle, he's actually continuing to work on the other component, right? So this is a reflection of that. So yeah, uh, there is an automatic machine which is performing greasing operation. Parallelly, the operator is performing his activity. Similarly, we can observe that in station 3 as well. It's a similar case wherein the part is bought in, put it in the fixture, and an automatic screwing machine is screwing the part. While this is happening, the operator is parallelly working on other things. So that is reflected here. Uh, but I think whereas in the last station, it's quite different. In the last station, the operator first presses the switch button, removes the main component, moves to a testing area, places the testing component into the tester, and then when tester is running, unfortunately, he'll not be able to do any other activity. Rather, he's supposed to wait until the testing completes. So we can also show that the operator is waiting here, and only when once the machine completes the task, the operator can continue on the other things. So like I said, any of those use cases in a semi-automatic setup, our system can able to understand. And now if I switch this to operator, you can see that the first 2 station is handled by a single operator. It represents that. So there are first 3 activities he does, and then he walks to station 1 and does the other activity in station 1. And here as well, when the machine is doing the grease activity, he's doing his other parallel activities, and then he walks back to the pre-assembly station and starts a new cycle. Okay, now let me show you some interesting insights the line balancing module generates and how you can effectively use that to achieve your required balance. So here we can understand that based on your takt time, your demand is 79 parts per hour, but actually you're producing 82, which is good because generally it's very hard to hit the ideal number. But if you are in a range of plus or minus 10, it's generally good and it is optimum. So yeah, so this is the insight you get from this particular card. And moving forward, we can see line balance metrics. So yeah, even looking at the graph, we can say that most of the operator are loaded equally. But of course, there are some cases where especially operator 2 and operator 5 who has a long ideal time. So hence it shows the line balance ratio is 91.32, or even line balance efficiency is 0.80. And then the other metrics is resource. So theoretically, it says there are only 4 operators required to achieve this demand. But whereas, the current setup has 5 operators, and ideally, theoretically, we need 3 machines, and it is as per that, and it's 3. That's good. But now, if you want to see what happens if I, try to hit that ideal number, will I be able to reach my demand or not? You can quickly do that. To do that, go on rebalancing, click on operators and say, give me a best balance. four operators and click on balance. Yeah, so before you dig into the details, I would first always look at these insights. So here it says the actual demand is 79 parts per hour. With this, we are able to achieve 79. Still good, right? And then line balance efficiency was improved from 80 to 90%. And it says the ideal operator required was 4 and the actual is 4, which is pretty good. And you can see that the ideal time has been reduced for operator 2 and operator 4. So I think this is a good balance, right? And now it's more balanced, it's more optimal line, and you can see the machine resources remains the same. Now let me show another example. Let's say I don't, yeah, actually, whenever you rebalance for four operators, it generally also redistributes the task between stations. It would say that all the activity done by operator 1 should be there in a one physical location called station 1. Similarly, all the activities done by operator 2 should be there in physical place or physical area called station 2, right? I mean, when I come here and if I click on this associate station, you can also see here, right? So, but what if you want to have the original line configuration, but whereas you only want to reduce the number of operator, allowing operator to move across different stations. To do that, again, you need to click on rebalance, go to operators, and write in the desired number of operators. Let's say originally this station had 5 operators, but I want to bring it down to 4, or let me do it for 3. And then here I'm supposed to click on this advanced option called balance operator without changing station configuration. So if you enable this, what system will understand that the requirement of the user is to make sure the physical layout or physical station configuration should be as per default or as per the current condition, but only reallocate tasks between operators. So enable this and click on balance. Yeah. Now we can see the results for 3 operators. So first I'll show the line balance chart. Now we had 6 stations in the default or current setup. All the 6 stations and load at each station remains the same because our goal is to keep the line configuration same, but whereas only redistribute tasks between operators. And when I come to operator balance chart, we can see that we only have 3 operators. And then when I come to Yamazumi chart, yes, I can see this as well. And also, if you can see this walk steps, the system has automatically added because the operator 1 is now working in 2 different stations. Similarly, operator 2 is now working in 2 different stations. I think that's more visible correctly here. Yes. So operator 1 would start his work in station 1 and then starts his work in pre-assembly station, then walks to station 1. After completing all the work in station 1, he walks back to pre-assembly station. Similarly, operator 2 will start his work from station 2, completes all the work in station 2, and then walks from station 2 to station 3. And then operator 2 is going to do all the work in station 3, and then he walks back from station 3 to station 2. So this way the system automatically understands that if a single operator is assigned to work in 2 different stations, there has to be a walk step which has to be introduced. Okay, now I'll talk about another new feature which we have recently added, that's about parallelism. Let's say, for example, if you look at all the steps here, all the operational steps that is required to build a component, sometimes, for example, let me take this particular step, pick and assemble clips to the main component. The process time for this particular operation is 15 seconds. And, this cannot be broken down into, you know, cannot be further broken down into smaller steps. So what happens if my takt time is less than 15 seconds? In that case, generally, uh, in industrial engineering, generally we are supposed to introduce a concept called parallelism. So for example, if my takt time is, let's say, 7 seconds, but my process time is 15 seconds, if I'm not able to break that process into smaller steps, the other way to do is duplicate that particular activity so that I'll be able to produce within the takt time. So we have that capability too. To do that, you have to again go to rebalance and then say, for example, I'll say, my takt time is 10 seconds. And then it's important to enable this advanced option called use parallelism. It adds an identical operation or station to make takt time. So, and then I'll click on balance. And here are the results. In this page, you can see since I told the system my target cycle time is 10 seconds, so it started, reallocating tasks and trying to make sure each resources could produce with within 10 seconds, and started doing that. And at some point, since these two we clustered it together, the system understood that I cannot break this down under 10 seconds. So any operations which cannot be done under 10 seconds, it duplicates. So yeah, it says now to achieve target time, you would have to have a duplicate station or a parallel station both doing same operation. And that's the reason it calls it as 6A and 6B. Similarly, even machine 2A and machine 2B, right? Because the sum of all these cluster is more than 10 seconds. So since we cannot achieve within takt time, it says that if you want to hit your target, you need to have two similar machines doing same activity to meet your demand. I think the other step which we saw, which was, the process time was 15 seconds, right? Even here, since this cannot be broken down in less than 10 seconds, it says if you want to achieve your target cycle time of 10 seconds, then you better have two parallel stations doing the same job or same operation to achieve the cycle time. Okay, I hope this video was useful, and our main objective was to enable users to model semi-automatic lines and achieve the balance they want to achieve. Hope this was helpful. Thank you.